19% titanium and 1% impurities such as nitrogen, hydrogen, oxygen, carbon, and iron. Therefore, it's composed of a single-phase alpha-Ta matrix of compact hexagonal structure. It's used in different industrial sectors such as aerospace and desalination sectors because it has several properties such as excellent corrosion resistance, good mechanical properties, a low density, and many other properties. However, titanium has disadvantages. It has a great affinity with hydrogen. Indeed, when hydrogen is present in the external environment, it can be absorbed in the surface of material. Next, it diffuses in the material, and when the solubility limit occurs, there are precipitation of inter- and intragranular hydrides. These hydrides weaken the materials. This is a phenomenon of embrittlement by hydrogen. Indeed, these hydrides lead an hardening and plastic strain of the material. In hard, they modify the mechanical properties as can be seen on the graph. And under stress corrosion, titanium grade 2 crack, I can see on the figures. The thesis objective is to avoid this phenomenon by limiting the formation of hydrides in the titanium grade 2. Because it's very important to control their properties during their service life. In order to achieve this, we will modify the crystallographic textures because in previous work that showed the crystallographic texture is a predominant parameter to control to avoid the precipitation of hydrides in the titanium grade 2. And in fact, hydriding tests electrochemically and in autoclave have been carried out. For electrochemical hydriding tests, I can say that some grains hydrate more than other grains. It's hard. There are precipitation of inter- and intragranular hydrides in the surface of material that seem to depend on the crystallographic orientation of grain. For hydriding tests in autoclave, two materials of titanium grade 2, T40A and T40B, are tested. At the end, the hydriding test, T40A hydrides, while T40B not hydrides. After to carry researches to explain the different behaviors between two materials, the main reason which has been highlighted is textures. Because these poor figures obtained by X-rays diffraction showed that two materials are different textures. In hard, these poor figures showed that we have deformation mechanism by shearing. The question we are asking is, what is the process technique that introduces deformation mechanism by shearing in the materials? The most abused is rolling. That's why we realize rolling tests during this project to obtain this kind of poor figures. We realize two types of cold rolling tests. Symmetrically, where the ratio of rolls velocity equal to 1, and asymmetrically, where the ratio of rolls velocity is different to 1. In the case, the ratio equal to 1.3. We realize two reduction rates 20% and 50% because we have two different deformation mechanisms. Here is a titanium grade 2 sheet before cold rolling. It has already textured because it has already rolled. After symmetrical and asymmetrical cold rolling tests, we obtain a titanium grade 2 sheet bent and deviated on one side. Titanium sheets rolled and not rolled are characterized by X-rays diffraction. The results of X-rays diffraction show that we have these textures. The grain in the material are oriented to 30 degrees relative to ND axis of the material. After symmetrical cold rolling, we obtain the similar textures. The only difference is that we have a rotation of grain around C-axis. After asymmetrical cold rolling, we obtain a new texture, the grain are a new orientation. I can say that pole figures of titanium sheets after asymmetrical cold rolling is different compared to these pole figures. In conclusion, I can say that only asymmetrical cold rolling change a crystallographic texture of materials. And in the rest of this project, we will realize hydrogen test in autoclave at different temperature. The question we are asking is, will we obtain the same result after hydrogen test? In perspective, we have other investigation to limit the formation of hydrides, pre-oxidation, anodization, and short pinning. This is a reference used for my presentation. Thank you for attention.